Good morning. Looks like I'm having some connection issues. So if the stream's choppy and this doesn't work too well, then I'm just gonna end the stream. End the stream. But you guys let me know. If anyone even shows up. What's on the list for today? Well, immediate mode stuff. So trying to get back to where I was, but make it a little better. So I've been sketching out ideas for what I think might be okay. I'm still not happy with all of it. I was doing this before I started streaming, so I'm still in the middle of working on stuff, so you guys get to see me. Kind of how I sketch out. Yeah, I thought so. Yeah. Yeah. No data. Yeah, Jesus. Let me, jeez. Let me try changing some of these settings. Oof, that is big. Is the stream still acting weird? I'm getting messages that it's kind of acting crap. Your mic is very staticky. Jesus Christ. So I think my connection is pretty shitty right now because it's affecting the audio and the video quality, which I do not know why. Seems good to you right now. Sounds good. Sounds okay. Okay. It's not bad right now. All right. Well, I'll run with it, but you guys let me know if it starts acting up. Then I'm not going to put you through that. I'll just kill the stream and work silently. So, all right. So yesterday was working on, let's see, render passes in the pipeline and getting those up. So right now I have it to where you can set frame buffers with render target attachments. Okay, good. So let's go to where I did that. So creating frame buffers, creating render targets that you can attach to the frame buffer, creating a pipeline, render pass, all that kind of stuff. And then down here, doing the binds. And then here's where rendering the scene to an off-screen buffer or texture. And then using pretty much the same binds except changing a couple of things, like the render target for this sampler. Passing in a default render pass, which clears the frame buffer and it just sets it to the back buffer, and then rendering out that texture that you had to the back buffer. So that all is working now. So pretty much what I have working in terms of the graphics API. Let's see. So pretty much all of this is working now. Okay, so I have it more or less to the state that I had before I started the refactor and the rewrite. It's just now better. Are you planning to release another game engineering video soon? Yeah, it's going to be covering this. This library is going to be the next. So the plan is to release a video covering Gunslinger, which is the library I use for all the videos, and probably do some small examples showing it off. That would be the next game engineering video that I have planned. And with that, probably do, well, not probably, I'd like to do like a game jam. Cool, yeah. All right, so what I'm gonna do today is, all this is well and good, right? I could release this today and you guys could run with it and start making stuff. It's capable enough to where you could start creating your own vertex buffers, index buffers, you know, all that stuff, your own pipelines and render passes. You can create your own utilities for loading data and pushing that into the graphics subsystem. You can do all that yourself. But I'm going to write some utilities now to where it'll sit above the core framework, very similar to the way Opengl does it. Sit above the core framework, you can include those, and then you'll have utilities to do more, I guess, simple handholdy stuff. Like if you just want to draw a triangle to the screen, right? If you just want to do some debug text rendering, stuff like that. It's useful for mainly debug stuff or simple UI. So that's what I'm working on today. So I'm sketching out kind of what I think some of that API should look like. This is how I decide usually what I want the APIs to look like whenever I write a system or a framework or anything like that. Is I just come out here and start writing the code as if I was using it. And if it feels good, then I'll run with it. If it doesn't feel good, I'll continue to change it up until stuff starts to make sense. I usually suggest doing that. Write the code as if you're using it, as if it magically exists. And if it doesn't feel good, then change it. Because if it didn't feel good to you, it's not going to feel good to the people that are using it. So one thing that Opengl does that I like is he has an immediate mode drawing utility that closely resembles OpenGL's immediate mode. Let's see, I'm not an expert, But what you're coding right now is some sort of modern OpenGL wrapper for Gunslinger. Gunslinger wraps the backends, right? So I have my own explicit rendering API, and what it does in the backend is it creates implementations that take that wrapping and it boils it down to explicit code to be fed into whatever backend you're using. So this backend will work with OpenGL core, but it'll also work with OpenGLES eventually, Vulkan, DX12, stuff like that. What's the reason you use C over C++? I don't like C++. Main reason. C++ is too verbose. I was watching a thing about some other guy's graphics framework last night. Actually, the guy who wrote Sokol. I was watching one of his previous C++ engines, and his video was how to do a simple triangle using this thing, and it was just ridiculous, the amount of C++ boilerplate stuff that had to be done. Like, virtually override this class and declare this class and link all these different libraries, and which isn't necessarily a C++ thing, but still. Another thing with this library is it's header only. So you can, I was covering this yesterday, you can drop it into whatever you're using, declare a couple of things as the implementation file, and then you're good to go. It's very similar to the SDB libs, if you've used those before. So what I'm thinking, okay, so what I'm thinking for the immediate mode stuff is very similar to the way you would do like OpenGL. You would do like GL begin, and then you would give it a primitive type, and then GL end, and this sets up like a vertex declaration. But inside of it, you would do stuff like color 4F, and then start doing your vertex declarations, you know, stuff like this. So I'm pretty sure this is the way to do this. So then what this does is that it sets in the back the GL driver to know that you're declaring a color vertex decl, and it's going to interleave with all of your position information, which is what you're setting here with this v2f. So the layout for this would look like it would be like a float through no, float 2, and then a float 4, right? That would be the layout decl for this. Yeah, and then if you did something like GL normal, I don't even know what that is. I think it's normal. And then you pass in a normal, pass in this. Then the declaration might be something like this, you know, whatever. I don't want to do this because I really don't want to have any, I don't know, I'm going back and forth on whether or not I want to have any explicit understanding of like, what is a color, what is a normal, or if I just want to do something like this, which is when you begin, you pass in a pipeline that you want it to bind. And then in the back, this immediate mode, so immediate draw I will have some dynamic array of just bytes. So vertex data, right? Something like that. And so then what you would do is you would begin a pipeline. That pipeline has some layout that's associated with it, right? So the pipeline's layout, so it has a raster state, and the layout is, let's say, float 3 for position, float 2 for UV, and float 4 for color. Like you can decide this, right? You declare your own layout, whatever you want. Something like that. And then what you would do is in here, you begin that pipeline and you start filling out vertex data to just push back into that stream. Like, I don't give a shit what you give me, just you're pushing it back into this vertex stream, right? So then you could do this, where you could do individual vertices. So you know that this is the layout specification. So let's say this is, you're doing a triangle. So this is vert 0, vert 1, vert 2. And you know the, what I'm also going to do with the layout for like the raster is you can give it not only the layout you want to do, but you can also give it offset and stride for each position. So I'm going to need to do that for the layout. That way, if you wanted to do them interleaved, you could have interleaved data, or you could do it to where you actually write all of one particular vertex attribute for all your vertices, and then you do another, and then you do another. So that's another way to upload your data as well. But let's say that it's interleaved and you've declared that, so you're filling out your vert data. So here's position, let's say it's that. Okay. Should be 3F. So you're writing 3 floats in, okay, great. And then, so that's position, now you want to do the UV. Okay, and then you wanted to do the color. This would be a total valid way of declaring that, is what I'm thinking. However, some of this you can see is kind of reused, so maybe not the best way to do it. So what I'm thinking as well is to be able to add something like this, which is interleave float, and then interleave U8, interleave U32, like stuff like this maybe, where what you could do is actually pass up a number, let's say a number of floats that you wanted to interleave into the data, and then you could pass what data you want. And so then what it would do is after each call to this, let's see, how would that work? So we need to know to interleave this data into like this, but then you had this as well, and then where to do it. Yeah, no, I'm not sure. Because maybe you would do like GSI vert. Right, but then the position you need to do, maybe not. So again, like I said, I'm not sure about how I'm going to set this up. I'm still thinking this through. I don't know if you'd call like, but then this really isn't useful to be able to do that. Yeah, I don't think so. It's basically like legacy OpenGL. Yeah, that's the idea, but it's not syncing with the GPU every call like legacy does. What it does is just buffers up vertex and index data in the back, and then it submits all that. The idea behind this is it's using the pipeline system, but you don't have to explicitly set those things up. It'll set up the vertex buffer for you. It'll set up the index buffer. Cool, welcome. Of course, John is planning to move this all to Vulkan. Yeah, eventually. It's set up for that, as you can tell by all the explicit stuff, right? So pipelines and render passes and all that stuff. So yeah, I don't think this isn't necessarily gonna work, 'cause this isn't gonna know how to interleave the data. Unless there's some way to be able to say like every other call interleave. I don't know. Jesus. Because what I'd like to do is be able to do something like this. Say interleave float. This is the number of floats that I want you to interleave in the data, right? And then in between each vertices, I want this to drop at a particular place. So actually I want this at the end, without having to explicitly say that. So one way you could do that, I guess, is keep some kind of count in the back. So you say, what's the stride? So interleave float, 4 floats, here's the number, here's the stride, right? You could do something like that. And then what it does in the back is that after it writes this information, it's going to keep an internal counter, and it'll drop this information. I could do that. Do a drop, resets the counter, keeps the current stride. But then what if you did something like this? Where you're like, you have 2 interleaves right after each other. So let's say you had 4, let's just, some other information you wanted to dump into here. Yeah, uint 4, you know, whatever. You just had some custom info that you want to dump into your vertex decal. It's totally fine, you should be able to do it. So, I don't know. Let's say you want them all to have this. I don't care, doesn't matter, right? So you need some stride and some offset to tell this how to interleave the data. And then maybe individual calls to things like this. Could do something like that. So when you call GSI3F, what it does is it counts 3 times size of float, right? And then it'll check against any of the interleaves that you have, and it'll mod against that. So, jeez. Hey, Vepo. I could do something like that. I don't know, does that seem confusing? So the idea behind this, by the way, I don't want to have shape stuff inside of here. I actually want this to be a little bit of a level up above setting pipelines explicitly, but it still uses the pipeline backend. And then I'll write another utility on top of all this to have debug rendering. So we'll have something like what I'm doing down here, which is debug render a line, you know, box line, sphere line, rectangle, triangle, and then text rendering as well. Stuff like this. And then filled objects, so rects, boxes, spheres, triangles, circles, cylinders, stuff like that. So you could just call, this somewhere in your program, and then give it an instance of the debug renderer that you have in your program. Stop. you do something like that, and then what it does in the back, if you do gs debug line, then it should call into the GSI. With like a line pipeline. And for this, maybe you give it like an X, Y, color, right? So do some, yeah, probably something like that. And then all it's doing is just dumping information in. So X, Y, which I imagine the line pipeline would be like a pipeline that has a layout of float 3, and then let's just say uint 8 4. Let's just byte 4. There we go. Something like that. And you would give it X, Y. Yeah, probably just line like that, and then I'll probably have like a line 3D. 4 byte RGBA. Maybe something like that. And in the back, so whenever you push on a new pipeline, what it will do is check against whatever the bound pipeline is in the immediate draw. And if it's different, then it'll queue everything up and then actually push everything out to its command buffer to be drawn. Otherwise, it's going to keep the pipeline that you had before. So if you did something like gs debug draw line, gs debug box line, you know, you do like a series of lines for line and lines, you know, something like that. This will queue up all this vertex information into a single draw call, and it won't change it. It won't be until you do a gs debug triangle, which is a filled object. It's going to put in another pipeline. Okay. Another thing that I've thought about is it'd be really useful, because the way this is working now is that it's going to have default pipelines in the back that it's going to assign for you, and you're not going to have any control over that if you use these functions. But what I'd like to do is have something like, what do I want to call it? Maybe like this, I don't know. Something like this, maybe. Where you could push on a custom pipeline for the immediate mode, and then you can push on attribute flags. So maybe one thing I'm having trouble with is where to separate all this in, because pushing pipelines should be something that's down in the immediate mode. That should be something that's possible. But these attribute flags are going to be to here in the debug rendering for particular shapes, because they have default layouts. Let me explain this a little more. So if you wanted to have some custom pipeline that has a custom vertex layout. But you want to be able to have the ability to grab a you want to be able to grab the vert data for a triangle, right? You don't want to sit there and write the vert data for a triangle yourself. You want to use the debug rendering to be able to give you that data so that you can dump it into your custom pipeline that you have. But it might not match the layout description entirely. Like you might have the same attributes, but let's say that they're shifted. Maybe you have the color first, and then you have the position, and then you have the normal or something like that, right? Or maybe you don't have any UVs. Maybe you don't have any normals. Maybe you don't have color. You should be able to grab that information from that particular triangle declaration that I'll provide, and then be able to use it in whatever pipeline you want to. So what I'm thinking about doing is something like this, where you can actually define GS debug vertex attributes like flags. And I don't know. GS okay. Like stuff like this, where you can have it in whatever order you want. Maybe you want the position here again. I don't care. Like I don't want to care what you want, right? So you can declare this, and then you can pass these flags up to the triangle. So typical triangle stuff. And then you pass the flags and the size of the flags. And then what it does is it grabs triangle declaration for you, and it pushes right, and then maybe what you do is let's make this simpler. So let's say that you want these things from a typical triangle, right? You want its position, color, and UV. But then you had some custom information that's a float for your stuff. I don't know. So then you want to interleave some floats for whatever. So there's the data that you're interleaving, and the stride that you want, and the offset that you want. So the stride would be the intention. The offset is going to be where it lies within each of the vertices. So the stride is what? Now let's just calculate it here. So size T stride that's total stride, and then the offset would be where it lies in here, so it's just this up to that point. No. And then you could call this to do your custom interleave data that you wanted inside of here. Because then in the back end for this GSI interleave, that'll look at this stride and offset, and any declarations that you put into here, it'll dump that interleave data at these points. Let's see. So let's say the triangle declaration. So let's say has, not hash, has position is flags. So the normal stuff that comes with all these shapes, right? Which every single one of these shapes should have information that you can generate for this stuff, which I'll provide. So if you want a triangle with position, color, UV, normal, then you can grab that information. So what it does now is it'll check to see if it has a position. Let's see. It's gonna have to do these. Jesus Christ. Let's see. Let me take a break. Let's see. Are you using Vim mode? Yeah, I use Vim mode for Sublime. Is it a pipeline? Is it a shader pipeline or what? No, not a shader pipeline. It's a explicit concept to, it's an entire render pipeline. So it's all the states that you have that you would use in order to describe how you want to render something, right? So it has the shader that's included in the raster state, but it has all of your rasterization states that you need. So like whether or not you're enabling face culling, what the front face is, or the winding order, how you're drawing your primitives, the index buffer, the element size. If you're using an index buffer, you need to provide that so that the GPU knows how to actually iterate through the data. It has stencil state, step state, blend state, all that kind of stuff. So it's an entire pipeline. And then the render pass, which sits on top of that, is like your color attachments, what you're rendering into, if you have any off-screen targets, the frame buffer that holds that stuff, depth, texture, stencil texture, stuff like that. And then flags you pass into that to tell it how it should operate on those targets initially. So whether or not you're clearing depth, clearing color, clearing stencil. All right. So like a normal triangle decal, like we were looking at a second ago, it's like GS 2F. I mean, maybe up here you interleave. I mean, you can probably you should be able to do this. So I should be able to do Vulkan, it would be a shader pipeline. Okay, cool. Yeah, it's kind of the same idea, right? Any plans for supporting MSV tools from VS 2019? I don't know what's going on with that. There's something with the STB libs that's throwing off the intrinsics, the like internal intrinsic library for VS 2019. It just doesn't compile with it. I'm gonna have to track that down. So I don't know what's up with that. So it's either drop STB, which would be a shame because it's a really good, powerful library, or figure that out, or just say stop using 2019, but I'd rather not do the latter. So let's say if has color, then we'll interleave color info. But also this has to, Does GS use any SIMD underneath? No, not currently. Yeah, so I'm not sure what his middle name is, but STB, S and B stand for Sean Barrett. And yeah, he's a sage old guy with long gray hair. So another thing, I need to keep this in mind if I want to do something like this, which this is all, again, I don't even know if I'm going this route. A lot of this stuff, just it changes as I go through. But if I want to do something like this and you want to pass in custom flags that's outside of what the actual vertex attribute declaration is, then I need to know where this stuff lines up. So I can't just interleave color info. I need to know where the color info would actually be interleaved into. It's either that or oh man. It's like if I have color, then I have to do this. So I'd have to iterate through the flags. So through all the flags. Which ones change? So the color changes. Yeah, but if you dump UV, that's going to be different. Yeah, I don't know about this. This might not work. This might not work. I always feel nervous seeing you write so much, not compiling. Yeah, I'm just writing. This is all commented out. So this is how I design APIs, is I just sketch stuff out. So you guys are watching me just sketch. Maybe not the most exciting, but I don't know if this will work the way I'm thinking, which sucks. Because I kind of like the idea, but the problem is maybe there's a way to just to call the interleave and then call this. I don't know. Yeah, this might be an instance of me just trying to do too much. So maybe I should rethink it. Rethink the purpose. I'll be right back. All right. I mean, one thing that could be what I could do is just do this and then pass back the attribute you want for the triangle. Yeah, I don't really like this either, because it really would be nice to be able to just do this. It really would be. The only issue is the interleaving of data, so maybe that's the problem, is stop trying to worry about that. Expect the user to, instead of interleave their layout, it's a yeah, instead of interleave data, it's just going to be giving specific offsets and strides that are, this is the entire chunk of this attribute of the data, this is this, this is this. Maybe that's to do, maybe I do that instead. So you give it the flags and then it goes through and it just iterates through the flags and dumps all the data for that thing. So if you had this, then again, it would do all this again. Actually, no, it would just iterate through the flags. So, you know, whatever the count of the flags is, then it would do these checks. If it has a position, then it dumps all position data. Etc. So then what this would be is that your layout would need to look something like all your positions, all your colors, all your UVs, and then any custom stuff. Syntax, guys, I'm just, it's in a comment. It's in a big multi-line comment block. I'm just sketching shit. This isn't actual code yet. This is me figuring out how I want to set this up before I commit. So I could do that. Instead of worrying about how to figure out how to interleave data, I could do that. That might be what I do. Because then it would just be a single thing. You pass back the instance of the debug rendering, the typical triangle information. Although what would that be? Does that even make sense? Let's say you didn't even have like a vertex attribute for color. You still have to pass back color shit? That doesn't make sense. One of the big issues I'm trying to get around is if you push on like a custom pipeline that has a different vertex layout, and then you want to call something like this is going to push on it'll push on like a default 2D pipeline, and it'll override whatever pipeline you had. What I'd like to be able to do is if you want to push on a custom pipeline, then you should be able to grab a specific attribute That's an interesting idea. Maybe something like that. So this won't push on a new pipeline. Instead, what it'll do is in your pipeline for this guy, it'll just push on vertex data in this order for this particular object, but it's immediate mode data. Or not immediate mode, like unit data. So this is for like a unit triangle. So the position information for a unit triangle would be it's like negative 0.5. Good Lord. Come on, man. Do something like that. I don't know. I don't know. I might be trying to do too much. Seems like with this kind of thing, maybe it's just hold hand and then that's it. Because otherwise it's just, it gets into too much of this type of stuff. Because I'm not really liking any of this. Hey, Dindy. All right, I don't think I'm gonna do this. I think it's going against just the simplicity of all this. I'll think about this stuff in the future, but man, I don't know. Yeah, I don't know. All right. But yeah, it'll probably be something like this, I think, for now. So what about textures? Enable texture, passive a text, texture unit, and then a slot. The only issue is that so for GSI, what would that look like? So GSI, enable texture, great. GSI end. Do you want to bind texture? Because then this would require bindings. The issue is allowing custom pipelines into this. Like, this is really muddying the waters. Because if I enable a texture here, at what point in here does it bind this? Does it bind the bindings for the pipeline in order to use? Like this, you're actually applying all the bindings. Because part of the reason for this is to make it easy, so you don't have to necessarily do all this to do like simple debug stuff. But maybe that's the point. Pseudocode overflow. Yeah. Well, I mean, this is how I do everything. So if you look at, let's see. All right, so this is all my sketch that I did for the first iteration of the graphics subsystem. Just writing notes to myself, going through. Some of this is code from like Banshee Engine, just looking at how he did stuff. Yeah, if you don't do this, I recommend it. It kind of forces you, especially if you're writing APIs for other people to use, if you're writing tools for other people to use, it forces you to think about how is it actually going to be used in production. If I just started, for instance, with the media mode stuff, if I just went down here and just started writing this, right? I just started dumping stuff into here. Very quickly, I'm gonna run into an issue where I'm not liking it, and then I'm gonna have to scrap everything. So what I like to do is get the main parts working and going to where I like it, and then I can start fleshing it out, right? It's like writing an outline for a script or, you know, story or something like that. Same idea. So I still kind of like this idea, this interleave idea. I think it could still work. You'd say what the stride and offset for the interleave is. Or really, it could just be the offset. What's the offset? Every how many bytes written do you dump in interleave? Not a bad idea. So then this will dump, you know, if the offset is 2 floats, then whenever you write 2f, it'll dump interleave and reset the counter. And then you dump another 2 floats and it dumps another interleave. I think that could be useful, and I think that'll definitely work. Look, I kind of like that idea, so I might keep that. So you begin, you dump a pipeline, you could set up your interleaves, do all this. One thing that's not clear is binding uniforms, if at all. In the future, what about lighting vertices? As you would do in usual immediate mode stuff. What about materials? It's like specularity. You know, diffuse, ambience, stuff like that you would typically have in like a Phong shading program. So if I enable textures for whatever it is I'm doing here, also pushing matrices. So if I want to push like a model matrix, what does that look like? You know, I want to do something like this. Do I even specify what this is? Do I just push a model matrix? I'm gonna look at Sokol how he does this, because he's able to push in custom pipelines and he uses that. And I'm not very clear what or how he would go about doing that. So if we look at, okay, come on. Holy crap, dude. All right, so kind of look at where he, you can push and pop pipelines and then enable and disable textures. So how? I don't see, unless you just have some bindings in the back. So let's see. Is this called apply bindings? SGL.bind. So command drop. So he runs his own command buffer in the back using VM. So what does he do when he does SGL push pipeline? Just pushes a new pipeline onto the stack. What does he do when he SGL enable texture? Texturing enabled. Enable texture, SGL texture. Set image, current image. Just setting some context stuff in the back. Set pipeline. SG get pipeline, pipeline ID. Make a pipeline. So I guess you push and then you load a pipeline with an internal pipeline, but then creating a okay. So then creating a pipeline. I see. So the entire idea behind this is you don't have any control over the actual pipeline that it's using. Okay. So you just create, but you can pass in a pipeline description. So you can. Let me look at an example. There's a dude that actually does, yeah. So there's some immediate mode stuff in here. There's SGL lines. So he's creating SGL pipeline. So make a pipeline. But it doesn't look like you can do anything. He's not doing anything with the shader though. SGL make pipeline, so let's find this. SGL alloc pipeline, init pipeline. Does it just set the shader? No, you can set a custom shader, it looks like. Right? So you have the description shader. In description, shader ID. Pipeline description. Description is the end description. Yeah, so he's just, okay, just caching that. And if it has an invalid shader, then you can set it to the default shader. So that means you can set a custom shader. I haven't seen anyone do it. I'd like to see an example of someone doing that. I don't see it. But I think his default shader, actually I can't even look because it's all bytecode. Yep. Let's see. Default pipeline, pipeline pool, default bindings, default image, the vertex buffer you're going to use. It's the matrix. So yeah, so this is what I did in my other immediate mode. So I had a stack of pipelines, stack of matrices, and you'd push and pop those. Let's see. Does he multiply matrices by any of this? think so. I think he just uploads it. Which again is another weird thing, because it's like if you don't use these matrices, then it's not going to mean anything in your shader. So I don't understand how he expects that to work. That's kind of a invalid assumption. .3f, just pack. Cell.rgba, so he just sets that. So it's like either don't allow the user to set a custom shader or make this valid, because none of this works for custom shaders. Unless what you do is when you push it back, like if I do matrix mode projection and I set a current matrix, and then I do like the way this, you basically set this up like a software renderer, right? So if I do GSI push matrix and then I do view projection, right? And then maybe in the back I had like a view projection stack. Or maybe I just push a matrix. You just push a new matrix and then I say GSI let's see. So basically do all this. I'm just going to copying this. Translate, rotate, scale. Okay, so that defines the model. Which actually you'd probably want to do GSI mat mul the VP, right? So your view projection matrix. You do that. But then that wouldn't necessarily work. So actually you would need to do like push the model matrix on. GSI push view projection matrix. Okay, so there's your view projection. Then you push on a model matrix, and so that's the model. And then when you go to do GSI 3F, you know, XYZ, but then that's kind of weird with if you did like GSI 4F, because they don't really tell you whether or not they should be affected by the model view. Man, it's just weird. Jeez. I mean, maybe there are certain functions that push back data that gets affected by the model and viewport matrices. Maybe. I don't know. I do not know. I mean, I could do that. If you did GSI 3F, GSI 4F. I mean, I'm basically writing a software render at this point, so. So this would be what you working on? Immediate mode stuff, or at least a version of it. For RGBA offset, color, model matrix. Oh, I can't do that. It'd have to be for the offset. For and then the data. It could be this. This is kind of, I don't know. This might be a little confusing and gross. Maybe not. Saeed says, this is really interesting. Well, I'm glad, because it's frustrating me. If you're wondering why it's all grayed out, it's because I'm just sketching the API right now, just kind of getting a feel for what I want. What GL version are you using? 4.1 is the min spec for the back end of this. I don't think I'm going to go below that. The reason it's capped at 4.1 is because I'm still using Mac with OpenGL, and that's the highest that Mac can go, unfortunately. Yeah. And the reason I use Mac is because I use this framework for work, actually. So I could do this. This is kind of confusing. So the idea is that you'd be able to dump any kind of data that you want into the byte stream. You ever implemented 16 or 8-bit floats in software? Actually, no, I have not. Have you? Not even sure what that would require. Setting up my own float specification, that would be kind of gnarly. There's nothing to really denote that this should multiply by the model view matrix. Like, that's what's so stupid about this, is it seems really wishy-washy. That's because I'm mixing like a lot of concepts here, right? So this push matrix model, that anticipates that there is something in the back end where there's like a matrix stack. That's pretty cool. You can save a lot of memory with it, reducing vertex and index sizes. Cool. If I ever get around to doing the software render, then I'll definitely look at that. So to me, this works okay. Interleaving, if you want to do that. Model matrix and all that kind of stuff, I'm not sure about, because it would be something like this, which is kind of gross, where you would have to say whether or not you're just dumping raw data into the stream or you're dumping data and then you want it to be affected by the model and view projection matrix. Could do it, you know. But if you want to do this, it has to be 3F or 4F. So maybe that is these two are particular because they get affected by this. Also, this means that in the back end, I'm doing all of this on the CPU, which isn't necessarily terrible, but you know. It kind of is. Maybe you do this instead. So you do GSI push pipeline, GSI load pipeline, GSI push binds. Because this binds would be pretty explicit, you know. And then what would this information look like? It would require the user to know about the internals of the immediate draw stuff, which just I don't like. You shouldn't have to. So I mean, maybe you just don't get a shader. You don't get to do custom shaders with this stuff. Maybe that's the thing. Like this is just really hands-on. You don't get to do custom shader. I don't know. Because again, it doesn't line up. If you do a custom shader, get rid of this. Get rid of this as well, because they'll just push pipeline, you just put it in there. Well, I guess you could load the pipeline. Immediate has no shaders in it. Yeah, the issue is it does in this case, because it's taking advantage of the fact that you're hardware accelerating this stuff. So it's not really in immediate mode. I'm not going to be doing, I'm not using immediate in the back end, if that makes sense. It's using my explicit framework in order to map down to this stuff. Just gets around having to, if you just want to do like some debug stuff and you didn't want to have to create like custom pipelines, custom render passes, custom vertex and index buffers, custom uniforms, custom textures, stuff like that. Well, yeah, textures you would. So maybe I just go that route. Like you don't get to do custom shaders with this. You don't get to do, yeah, maybe that's what I should do. I don't know. Does that seem like a cop-out? So you could do custom byte information that you dump into it. You can push and pop matrices. Although now at this point, it's like you don't do this. You actually do V3F, V2F, V2F, right? And in the back, it's expecting to have certain things. And then you would do how did it work to do fancy effects? There really wasn't much you could do. There was no programmable shader pipelines or anything. It had lighting you could do with it. You could declare normal declarations. You could declare UV and color declarations. You could do texture matrices. So you could bind textures. There was some limited lighting, but it was all Phong shader. So you set up materials. So you could do material declarations, but the materials were Phong based, right? So you would have like specularity, and then you give diffuse and ambience, stuff like that. It'd be cool to think of a way to be able to make this work with like PBR. That'd be neat. But yeah. This is really the thing that's killing me, is I would love for this to be able to work with like custom shaders that you wanted to define. That'd be cool. You do like a custom pipeline. The only issue is you have to be pretty hands-on with it, and it goes against the spirit of being a little more hand-holdy with immediate mode stuff. No, it's whatever you want to use. I don't have any conversion between, there's no custom shader language that converts down to whatever the back end is. So right now it's whatever you're using this for, your shader needs to be written for that back end. I will provide something like using Spear V. So you could convert your shaders to Spear V and then you could use it across. I don't know if I'm going to do anything, not in core anyway, maybe separate utility, but I don't know if I'll do like a custom shader language that boils down to some back end. I don't know if I want to waste the time doing that. All right, so I've got a crossroads here to decide on. It's, do I allow the user to do custom shaders? And then you do stuff like this. If I could figure out a clean way to be able to push uniform binds, then this would probably work. But then something like enable texture just wouldn't make sense. It really would just come down to this. We're just like, do this, push in the vertex data directly. This is more like a vertex data builder than anything. I shouldn't really care about that though, because again, it's just filling with bytes. Man, this sucks. That might work. if that's... Yeah, that sucks. Your math library. What were your macros that were difficult? Could do something like this. This is gonna... It's okay. I still think this is too explicit though. Maybe I provide it though. Because this is all push pipeline stuff that just, fuck. I needed a macro to define function names, but with more than one type. Maybe you can give me an example. I don't know, would you guys be okay with this? So you push on a pipeline, tell this that you want to push bindings. You load your uniforms into that, so you pass a handle and then whatever uniform data you want. Load your samplers, handle, texture data. And then do your vertex declarations or your vertex data. You dump that. Of course, this just dumps vertex information. There's no index information at this point, which kind of sucks. Float 4, float. So mul, float 4x4, and float 4, I need a macro to generate that. C11 port of GLM. Okay. I'm guessing you wanted something more than not GS, geez. So mat mul. So let's call it like so you have some, how would it be used? Define, let's see, GLM call func XOR. So okay, the return call func vector type name. Yeah, that is crazy. Yeah, I'm not even gonna try to think about that. GSI index 2. And whatever, just say it's that. Could be something like this. Offset. I might be okay with this. Let's see. Overflow. Hey, I'm not very good at C. Are you coding a game engine? Yes. It's a game framework, really. Multimedia framework. So you could use it for games or anything else. Like I said before, I've used it for in-house tools for my job. What's up, VMA? Yeah, there's a link to the code below, but it's it's not the working code. By that I mean it's not what I'm developing right now. It's a previous version. By previous I mean last week. I'm moving it all over to being header only. So you wanted to do quaternions. You might want to do quaternions, operations between matrices, vectors, scalars. Yeah, definitely. Yeah, definitely. I use quaternions a lot. So I would expect any math library to have quaternions. Oh. So this might be something I do. I'm kind of liking this a little bit. So to load a custom pipeline, you would push on a custom pipeline. And then you would need to push, let's see, so let's do this. So you push a pipeline, that pushes a pipeline on the stack, just to be consistent. And then you do GSI load pipeline with your custom pipeline. And then you push on custom bindings because you need to do that. And you load your uniforms, you load your samplers. right? Does that make sense? And then you can declare to interleave data. You give it an offset. That'll set an offset counter. And then here's the data that you can interleave. And then you start declaring your vertex data, right? So let's say we're doing a triangle. All right, so here's first vertex, here's that. We know the layout because it's in our pipeline. So we are the ones writing it, so we're aware of our pipeline layout. So we have V3F, V2F. So let's say that's like position and UV, and then we have an offset that's going to be interleaved, you know, whatever this offset is. Let's define it here. Let's say the offset, so the color offset is size of F32, so 3 F32s plus size of 2 F32s. All right, so that's 5 F32s is the offset, but we'll just do this so that it's explicit. So we give it an offset, sets an internal counter for this interleave data, and then when you're going through and adding these vertices into the byte stream, it'll count. So here's 3, here's 2, we hit 5, and now here it dumps the interleave data. You know, here's 3, here's 2, dump interleave data, right? So it'll do that. And then you want to be able to push in indices because you want to do indexed rendering. Then you can push in this gnarly little thing, which is index, let's say index, here's the type, so it's U16 internal. Actually, we don't need to do that because the layout will have the internal stride type. So we'll just say index list, number of indices, and then the list of all the indices, right? So the actual declaration for this would be like void gs index list un32 count, and then that. So this could cover custom stuff if I think about it some more. The only gnarly part is that it's a custom pipeline, so you have to define this binding information. So I just need your uniform handle, so any uniform handles you want, and then uniform data you want to pass up, and then any sampler handles. So this is uniform buffer. And then texture handle, I need the sampler handle as well, which is just here. Which, how do I do that? So type, so the buffer, sampler, and then the actual texture you're binding. So it's the exact same thing. So uniform data, that. For the handle, this the size of the uniform data is actually declared inside of the handle itself. So you don't even have to pass that up. That is handled for you. You just have to load uniforms, and then you can do this as many times as you want. I believe. Now, where could this go wrong? Because the way this works, and it's going to work, is that you're passing in a GSI object. Okay, so let's just GS immediate draw interface GSI equals, you know, whatever, get that. So each time you do this, you're passing in this GSI object. The reason for this is that this thing holds a command buffer internally. It also holds all of the information that it has to build up. Why immediate mode will it be the only option? No, of course not. This is the actual graphics backend. This immediate mode is just a utility that's sitting on top. But this is an explicit framework in the backend. So the way this works is you have this as an abstraction layer that sits directly on top of whatever actual graphics backend you're using, whether it be Vulkan, DX12, DX11, OpenGLES, WebGL, you know, whatever is being used. Here's the graphics implementation for the particular backend. So for this one, it's OpenGL. So it takes all that information and it boils it down to actual OpenGL calls. And here is an actual program using all of that stuff. So declaring all this data explicitly, right? So vertex data, index data, vertex buffers, render passes, you know, all that stuff, very explicit, the way you would do like in, again, like DX12 or Vulkan, setting up all your bindings, all of your uniform information, and then here's the actual draw calls that you do, right? So this is all possible. This is all already working. So what I'm doing now is making a more simpler pipeline that sits just on top as another abstraction layer in case you just wanted to do like simple immediate mode drawing. That's the idea. So I'm sketching out what that might look like. Yeah, Saeed, I like the generics in C11. I just wish C11 was more widely available. It's not like MSVC doesn't support C11 at all. GCC supports most of it, I think, but that's the only reason I'm not using it. So I'm just sticking to C99 because it's pretty much all the features of C99 are available in whatever compiler you're using. So this might be what I do. Still not sure. I don't know. You guys tell me, does this seem all right? Because really all this is doing at that point is, like I said, it's just a vertex builder. You still have to define a pipeline. You still have to define uniform information. So what would this actually look like then? So you wanted to call debug triangle. All right, so what do I expect that to have? Probably like X, Y. No, it'd have like A0, or let's just say ABC, which are V2s. Color. Whatever else. Because it would just be all this, right? So GSI load. Which it's just a triangle, so it's not what you do. But then what about for this triangle if you wanted to do like a custom matrix? Yeah, it's not gonna work. Man. Because it's gotta push sampler stuff. I might just do this and just call it end of the day. Because the other side of it is just you don't get to define pipelines. GSI itself will define its own pipelines, and then you just say what you're beginning, and then it'll upload that pipeline, and that's it. So then you declare color information, textures, coordinates that you want for the verts. If it's textured, then you can enable texture, load a texture for the binding. This might be the simplest thing. Because then for holy crap. Yeah, so it would be this. There's no texture enabled, so you don't do that. That would be it. Not tired, just frustrated. But usually the way this goes is that I'll spend a day on a new system and just kind of sketch stuff out, and then I'll sleep on it, have some kind of revelation or something will hit me, and then I'll move towards that. It's usually how that goes. So this is just a necessary step. But I could do this, and this would be fine, right? So again, the entire point is if you just wanted to do debug drawing, that's really it. Not that you wanted to draw like a triangle with a fancy shader effect on it. Something like that. And we really, this could be, well, no, I do like that. Yeah. Anyway, what time is it? I will probably stop here in a second and go in a couple hours. Yeah, I understand. You'd have to really kind of think about it. I mean, you could do it. So one of the things that I wasn't sure if I was going to be able to support was like typed containers, right? So let's go to like the container types. Let's take a minute and show you some containers. So we have a generic byte buffer. It's just U8 data. I use it for all of my VM stuff. So you can write generic data into it and then read back that data into a value pointer. Or you construct a new variable and you can read that. You can bulk write into it. So I use that for like the graphics implementation. So for the command buffer stuff, right? So if we look at begin render pass. So you push a command. The command right here is just write an opcode. It's like a U32, size U32, write that into the byte buffer. Write the handle ID for the pass, write the count for all the actions, and then write the actual pass action that you're gonna do. Again, this just dumps bytes into a U8 stream. And then in submit command buffer, iterate through all the bytes, and then parse the data packets like this, right? So an opcode and then a data packet. So that's really useful. Let's see, dynamic arrays. So these are typed. They just evaluate to basically a GS dynamic array of some type. Evaluates to that through the macro, which is useful because that means that I could have something like 32 array and then set that to null. And using the macros that I have, you could push data into that array, you know, and it's completely type safe. So if I wanted to do something like this, it would complain about it. And then you have pretty much all the C++ standard template library stuff that you would expect. So push, you can pop. You can also index directly, since it is just an array, like a C array. You can get the size of the array, you can get the capacity of the array, because all this does is it stores a header information. So array header. This is the actual declaration for an array, and all it is size and capacity. And so whenever you allocate the array, so you have some t pointer of an array, right? So it's some block in memory, right? When you allocate it, all it does is it allocates the size of whatever this size is, and at the beginning of the array, it allocates this header. So then whenever you want to, and then you return the pointer to this spot in the memory. And then whenever you want to grab stuff like the array size or the array capacity, if you want to check if it's empty, which again is just checking if the size is 0 or not, right? Then all it does is it grabs that pointer and it looks backwards because it's expecting it to be contiguous, because it is. It looks backwards for this header information and then it reads. Yeah, this isn't my idea, by the way. This is Sean Barrett's idea. This is a stretchy buffer idea. But I've taken this and I've run with it with different types. I've also used his idea to do a slot array, which I've talked about that before. So I have a GS slot array of a particular type, which is the data that it holds. So what this is a dynamic array. So it's a dynamic array, so the thing that I just told you about. And it has a a data array of type T, and then a UN32 array, which is the indices that lead into the array. So it's a double indirection array. The reason this is useful, I've talked about before, is that if you have some dynamic array and you want to have references to it that you pass back to the user, you would have to pass back either an index into that array or a pointer. Both of these are bad because if the array grows, that index is no longer valid. If the pointer grows, or if the array grows, the pointer is no longer valid either. So what you do instead is you hand them back a slot array or a slot index. So whenever you do like slot array insert, the slot array and then the val that you want to insert. So let's say that this is our slot array, and the val that we're going to put is like 10. Then you get back a UN32 index. And what this does is whenever you call GS slot array get with the index, what it does is it looks at slot array, the data indices at that index. So it's a double indirection. This is basically what the macro boils down to, is doing this. The reason this works is that your index into the indices, it always maintains that index. It will never delete it from you. So as long as it remains valid and you don't delete that index from the slot array, then that handle will always remain valid. And it always points to a consistent place in memory because it's an internal index that points back to the original data in the slot array. So that's another container that I've defined and I use quite a bit. I also have a slot map. So the slot map works exactly the same way. The only difference is that you can actually provide a key, and then you can provide a value that key hashes into. And then in order for that to work, I have a hash table, which again, I got this from Sean Barrett, where you can define any key, any value you want. Hash table, and it works the exact same way. So you can set that to whatever you want, and what it does internally. And again, not my idea. This is totally Sean Barrett. So let me find the hash table insert. All right, so this is a gnarly macro, right? What it does is you give it a pointer to your hash table, you give it the key that you want to insert, and then the value. What it does, so you were asking a second ago, you don't understand how you set it to null. What all these functions do upon insert, and a lot of the other, is it does a null check, and if it's not existent, then it initializes that for you. Then what the hash table does, it's kind of standard for a linearly allocated hash table, is that it'll grow depending on the load factor. So it grows the hash table, and then it sets a temporary key. That way I can have the size of the key. And then what it does is it actually hashes all the bytes of that key type. So you pass in a particular key, it'll hash the bytes directly using a 64-bit hash. And then it looks for a hash index and places that data directly, which is all down here. So this is gnarly shit, but it works. And it allows you to be able to do stuff like this, where you have a hash table of any type. Again, I could have like whatever you want, I don't care. Fill that with whatever data you want, and then you can give this, you could say that this is a hash of a hash type that maps to a U64, and that'll work, because all it's doing is hashing the bytes. And then like I said before, the slot map is the final container, and you can do the exact same thing. So you could map, any kind of type down to any other kind of value. But what it does is it has two levels of indirection actually. So whereas a slot array had one where you give it an index, the slot map, what it does is it hashes that key into an index. So it actually goes from, hash of U64 to a slot array index, and then use that to look into the slot data to get back your actual data that you want. So those are the Gunslinger containers that are available. But figuring out how to make this stuff work was a bit of a challenge, especially for stuff like this, of using the comma operator in a lot of this. Yeah, I do that a lot. Oh, the macro trick where you count the args. No, I don't use that. I do. So I do use it this way, right? Where you pass an account and you do that. I don't know the other trick you're talking about. It's probably something I should do. Because I'm sure it's a trick that'll help me out somewhere. Let's see. Yeah, this looks all fine. So you've made your own printf. Yeah, that works. Interesting. I like this. This is cool. Yeah, so you go through and you look for specific declarations, right? So you say that it's going to be a vec2, you look for that in your printf when you're parsing the string, and then you read the data a particular way. Yeah. Yeah, that's pretty cool. That's actually a useful way to do the print. The only thing I don't like about it is, well, I mean, I guess it's not that big of a deal, because the user doesn't necessarily have to use your declarations. As long as you support standard primitives, I think it'd be fine. 1.1, I guess that's okay. If you wanted a particular, yeah, I see. That's an interesting. The macros to construct the vectors, you mean these? GLM vec4, vec2x. Oh yeah, that would be useful because this means vec4 v3. That's weird. So VLM. So with this macro, you're expecting to have two v2s. What happens if someone passes in? If someone passes in like a scalar value and then a vec3, does that work? Oh, it uses the variac. Okay, yeah. Yeah. Man, the variatics are cool. It's just a shame that, like, I write them out. I write them out completely because I can't use them. So I didn't even consider that. When I was looking at this, I was just thinking that maybe you had some. Yeah, it should work if you're using the generics, but if you're just using regular variatics in C, like C99, you'd have to have some way to be able to count the arguments in a macro, and then depending on what those are, you would do something with it. But then that would break down because you don't know the type. Unless you say, you know, get the size of this particular argument, get the size of this. If it's this, do this. If it's this, do this. So you could do that, I guess. This is cool though. I would like to figure out a way to be able to do this, where I could just have one macro and then in a way do function overloads, which you can. It's just gnarly to do it. Pretty cool though. Thanks for showing me. Like this would be useful. Just to be able to do like GLM vec2, pass in a single thing, and then if it's just that single float value, then it fills it out for both X and Y. That would be neat. Because right now what I have to do for mine, like I have a GSV2, that's wrong. Where is it? Yeah, this GSV2S, let me do it like that, where it constructs it with a scalar value, right? So it'd be cool just to be able to do this. And then pass in, which, I don't know, maybe there's a way. So like, yeah, so you need to be able to, I need a way, like a macro, to be able to count the number of arguments. And then do something with that useful. So if I had some way to be able to say, you know, count args, and then do like a GSVec2 constructor like this. That would be cool. Because if I could just do GSV2 and get rid of all this other bullshit, that would be cool. I'd be okay with that. But yeah, I'll look into that. That'd be kind of interesting to figure out. But you can do it in C99. Okay, cool. Yeah, I'm gonna look into that. I'll probably check that out after lunch or something. And then think more about this. I mean, what's the ultimate goal with this, right? Just doing debug rendering, not to be like a fancy way to do all your rendering, because that's defeating the purpose, I think. So I think maybe this entire thing should be, listen, I'm gonna have debug shaders in the back for you. You're not gonna be able to design pipelines and then pass them in. Then I could do stuff like GSI, like lighting, like actual, like maybe if you wanted to do simple stuff. I don't know. Maybe I do stuff like that. I'm trying to resolve myself to being okay with this, instead of going overboard trying to think of this. Because I think the idea is for it to be simple, for you to be able to do quick stuff, and I think going this route, it kind of defeats that purpose, and now it just becomes a headache for people to even use. So then what was the point in the first place? If that makes sense. So it should be something like this. I think maybe that's what I do. Anyway, all right, I think I'm gonna head out. All right. Thanks guys for dropping in. Like, subscribe, comment, join the Discord, all that stuff. How does that work? How does what work? What are you talking about? Unless you're talking about all the macro stuff we were talking about before. Then I'm not sure, and I'm gonna have to look at that. Declare a variable of that type? No, you can do that. Oh, so I could have some would it be like that? And then the macro would call into this thing with the count and then the number of arguments. And then you would, depending on number of arguments. Is that kind of what you're thinking? Okay. Then you have sequences to do that. Okay, cool. All right, I'm gonna look that up, because if I could do that and have operator overloading, then that'd be cool. Uh-oh. I'm not sure what you're saying. Zach got. I would be surprised if there's not a way to do it. I mean, I've done some pretty funky macro stuff in this library. So again, the ability to be able to do something like this have it work. I mean, that shouldn't work in C, right? At least you don't expect it to. Right. The type name will also get replaced. To GLM type float X, GLM type float Y. Yeah, because you're saying 2 arguments, right? And then here's the type, here's the value, here's the type, here's the value. So you tell how to read that. So does that mean that you have to? Yeah, but for that particular method, say you have to give it like it has to be a void pointer, right? Because you can't pass in the float directly. Otherwise, you have to define that function. Right. So it would be something. Oh, geez. So GLM vec2 constructor. You went 32 count. Yeah, and then this. And then you would have to read arg types, construct based on arg type. And then GLM v2 as a constructor would be however you get that argument data. I have no idea. So that's the part that I'm funky on. It would be this, and then you call GLM back to constructor with arg count, and then whatever you decide this is. I'm not sure how you define this either, but that's how you would have to set that up. Actually, yeah, I don't know. I don't know how you do that. Cool. I'm gonna look that up, figure it out, because this part I'm unsure about. And then this part I'm unsure about. Actually, and then getting this part I'm unsure about. So how you actually grab this information in order to be able to pass it back, that's what I'm unsure about. But damn, I love comma operators, man, because I could sit here and define all kinds of stuff that I want inside of here and just do tons of different operations, and then the return only cares about this. It's really useful. And I just found out about that not too long ago. I've never used it. All right, well, I'm gonna head out. See you guys. Thanks for dropping in again. All right. I will talk to y'all later. Bye.